so one thing I realized that I was silly about last time, and I want to make sure we're on the same page, is let me write a multi-line basic program, and let's look at the tokenization of that and whatnot, because I think the example I gave you guys was a single line program, and that left one thing kind of unclear. So let's just make something. Um, okay, nothing special. Oops. Huh? To do what now? Oh, escape. Yeah. So yeah, escape on the real Commodore. There's a button called Run Stop that will do that. There's no actual escape key on this on the real thing, but on the in Vice, it's just the escape key. So okay, all right. So I just saved this to my disk image. Okay, nothing particularly special. Let me get my terminal open and launch Droid. Um, hey Shane, how's it going? Okay, so let me go to, I have this on the desktop, class January 20th. Okay, and let me go to desktop here. All right, so I just created this program, silly, and if I view hex, well, let me start with view basic, right? So this obviously is the detokenized form. That's basically all I just typed in, right? And this would look the same as if I typed this in a modern text editor, whatever. Okay, but the hex I want to talk about a little bit more because, well, there's sort of two issues here. One is the example I showed you guys last time was not a multi-line basic program, and so that left the pointer issue a little bit unclear. Okay, and I want to make sure that that part's clear. So let's go through this. And what is 0108 at the beginning? Yeah, so that's the starting memory location where this program should be loaded into. Okay. And for the case of a basic program, it always must be in memory address 801. Okay. And so why is it 0108 if the address is going to be 801? Yeah, so it's always listed in low byte first and then high byte of a 16-bit number. Okay, just get used to that. Okay, so that's true about every single basic program. They always start with that. Now, when we start doing stuff in machine code, that's not true, but there will be a start address at the beginning. Okay, all right. 0E, 0A is what? The whole thing is the pointer. So 080E is a pointer, and it's going to point to where the very last character of that line of the basic program. Okay. Now, here's the thing. Which character, what did I point to? I pointed to the thing that's at address 0D, right? Not 0E. Why? And Rippy, silence. Okay. So it's sort of off by one from what you think it is. Okay, and the reason is, what's the starting memory location of a basic program? 01, 0801. Okay, so are we starting in 0800? No. And so everything is sort of off by one from what you might think it is looking at the hex dump. Okay, so what I mean there is looking at my addresses here, address all zeros, right? The very first byte of my program. What memory address does that get stored into? 0801, 2, 3, 4, 5, 6, 7, 8. And you see how everything's off by one? Yeah? Is that annoying? extremely. Like, I don't know why they did this, because memory address 0800 is unused. It just has to be zeroed out, okay? And this is why you have 39, however many, and 11 basic bytes free, not 12, because they started at 0801 instead of 0800 like a sane person.
There's got to be a reason to do that.
There must be. What actually is probably more likely is that it's a legacy thing from like the VIC-20 or the PET, and there was some reason on those machines that it needed to be different, and that for compatibility reasons they just kept it the same on the Commodore. That would be my guess if I had to make a, you held a gun to my head. Okay, but right. So what the pointer is pointing to is the very last character in that line. Okay, which in this case is the 2-2. Okay, so what is the 2-2 character? Yeah, the quotation mark at the end of hello. Okay, and then in the next memory space we have what, 00, and what does that tell me that I've hit? The end of the line, okay, or the start of the next line, depending on how you want to think about it, right? Okay, and then what is 1C08? Pointer at the end of the second line, okay, and then 0099, or I'm sorry, I misread that. Okay, 1C08 is really a pointer to memory address 081C, right? Because remember the order. All right, that's the end of the second line. Second. All right, 1400 is this is 20. Okay, what is 20? The line number. Okay, and the line numbers are 16-bit quantities, not 8-bit quantities. So low byte, high byte. What's 99? The token for print. What's 20? Space, quote, WORLD, quote, end of basic line, double is end of program. Okay, so does that make sense? Okay, so I wanted to make sure that that was clear. Okay, now, right, so the tokenization. And so, yes, the thing that's really annoying here is everything's off by 1 from what it looks like in a hex dump, because a hex dump is going to start at address 0, but where do the basic programs get loaded? They get loaded in starting at address 0801. Okay, so that off by 1 thing is irritating as hell, but again, there's got to be a good reason for it, and I don't know what that reason is. Okay. Okay, so questions on that? No? And if you had 50 lines of basic, it'd be the same thing. Just there'd be, pointer at one end, line number following, 00 to end the line. Okay. Okay, good. Now, so the next thing I wanted to do is, let's say I open up a text editor, whatever, Atom, Genie, VS Code, doesn't really matter. Okay. And I make a new program. Huh, gee, this looks familiar, doesn't it, Rippy? Yeah?
Wait, go back.
No.
Wait, no, go back. Go back. I got it ready. Yes. Let's go.
Yeah. Okay, so if I just do right, whatever, okay, and then I don't know if I actually put one in here. Well, yes, okay, there's that. So let me just change it to all uppercase, but whatever.
It's gonna print those really weird, like, hex key characters and don't do that.
Okay, so if I just type this in a modern editor, and by the way, in I think both Atom and VS Code, and probably in Sublime Text, and any of the other nice editors that you guys like to use, you can get syntax highlighting for Commodore Basic V2, or many other versions of Basic. So it'll highlight things nicely. Okay, great. Right. So if I save this, and I got to put it somewhere, so let me just dump it on the desktop because I'm being lazy. Okay, and I'll save it as, I'm just going to use .bas as my extension, right? The extension doesn't mean anything to the computer. It just means something to you as the human, right? Okay, so I've got this thing. Great. All right, now what I really want to do here, okay, is let's look at the hex dump of this, of the file I just typed, okay? So 313020 blah, 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 okay? What is all of this? Yeah, it's the raw ASCII, right? So the thing I just typed in my editor is just a plain text file, okay? There's nothing special about it. And so how is all of that text encoded? It's all in ASCII, right? Because we're working on a real computer, not the old one, okay? So looking at the hex dump, what do we see? 3130, that's just the character for 1 followed by the character for 0. Then there's a space. Then here, let me blow this up a little bit so it's easier to see. Okay, is that better? Yeah, okay. So what do we got? 3130, that's character for 1, character for 0, then there's a space, then there's a P-R-I-N-T, then there's a space, then there's a quote, then hello, then there's a quote, and then there's a what? 0A. What is that? Yeah, that's the end of line character in ASCII. Okay. And then 32 and 030 is the 20 at the beginning of the next line. Okay, good. All right, fine. So then, and then what's at the very end of the file, or the last character, which again is a line break. Okay, so end of line character in ASCII. All right, so if we go look at ASCII, the ASCII table, okay, or the Petsky table for that matter, 0A is the character code for a line break or end of line. 0D is the character code for carriage return, which is like hitting enter. Okay. On the Commodore, 0D is how you would know that you'd hit the end of a line of a non-program file. Okay. So a sequential file, we'll talk about what those are in a minute. Okay. So like the idea is if we had a text editor on our Commodore for just plain text, not typing basic programs, then I would know I hit the end of a line by looking for the 0D character, the carriage return. Okay. And on a modern machine, it's encoded such that the end of line is 0A. Okay, those are just two different ASCII values. That's not really a huge deal, is it? Okay, so for the second assignment, what are you guys doing for that? Right? So the first assignment, what did you have to do? Write a program that prompts the user to type in a string. They type something in, and then the program prints it right back out. Okay, so that's step one. What was step two? You copy the tokenized version over using Droid. So you've got two files, a .bas file that's in plain text and is basically just whatever your program was, right, in untokenized form. Okay, you've got the .prg file that you copied over from the Commodore that's tokenized, and then some sort of document explaining how the two are related. Okay, all right, now, okay, so great, you did that, or about to do it, because it's not actually due until tonight, but whatever. Yeah, I think I have to put a time on it, so I think it's 23:59, but whatever. Okay. All right, so that part was not rocket science, hopefully. Okay, then what? What do we want to do with that? So what's Thursday's assignment? Well, okay. All right, so what do we have here? We have, and I've just hex dumped it, right? It's just a file that contains a bunch of bytes, right? And what are all those bytes? Well, there's line numbers, there's words like print, there's things in quotes. For the assignment for the first one, right? How do you get user input? What's the basic command that you need there? Input. Okay, so there might be the word input someplace. Okay, and so what I basically want you guys to do is to write a program that can take this and spit out what? The program tokenized code.
So you want us to take a raw Hex Dump, one that is like non-converted, and then convert it over.
But your program's going to do that.
Yeah.
Right. Okay. So here, right, either in, I've typed it here in Atom, right, but the hex dump is down here at the bottom of my terminal, right? So this is just the data that's in a file. Okay. So I want you to write a program that takes this in and is capable of spitting out the corresponding tokenized basic. Okay? Does that make sense? In some sense, yeah. Like that's the way I'd be thinking of it.
Yeah, you're gonna run some things where you have to know, well, at least you know what it is line is. You have to start with the line. You have to make sure the pointers are proper. You have to make sure all the tokenized libraries are up to date.
Right. Okay. Yeah. So how do you know when you've like to process a line? Well, first off, what's the very first two things that have to be in the file that's getting created?
0108.
Right. 0108, because every basic program has to start with that. Okay, great. So that's done, right? That's the easy part. What needs to immediately follow it? A pointer, right? So 2 bytes, that's going to be a pointer to the end of the line. Now, do we know necessarily how long that line is going to be? Yes and no, right? We don't necessarily know off the top of our head it's going to be 7, right? But we can determine that because how many characters are in my line here? Well, I could count them, right? What? Ah, yes, that also would work. You could just start scanning until you hit the OA, which is to say counting the number of characters in the first line. Okay, but does that tell you how many bytes you're going to need when you tokenize it? Not, they're not the same number. Okay, what I mean by that is how many characters does my first line of my program, or I mean, my basic file have here?
I mean, what you're saying is that you just need to make sure you're double checking that if you're finding keywords to compress them down to the token.
Right. So you have to, like, there's some arithmetic to be done here, right? So I can't just count 1, 2, 3, 8, 9, 14, 15, 16. There are 16 characters on that top line of the basic source. But does that mean I need to allocate 16 bytes in my tokenized form? No, because how many bytes do I have to allocate for print? Just one, not all 5. Okay, why? Yeah, okay. So what would have to happen here, and let me just sketch this on the, well, I won't do it on the board since Shane is online today. So let me just open up this. Okay. All right. So I would have to have that for sure, right? Okay. So let me just skip past that and just ignore the 0801 at the beginning because we know that that has to be there. Okay. So what has to come after that? A pointer. I'll figure that out later. What has to come after that? A line number. What has to come after that? Well, not yet, because what's in between? A space. Okay. Did I have to put that space in there?
Can we just not use spaces? Because like you can like easily get rid of them in the system.
Yeah, but how do you know the user's not going to put in spaces?
No, I mean I'm saying that like it may see a space that's not within quotation marks.
Uh, I mean, uh, but how is it in the program file? There is a space.
But it runs the equivalent program without the space, right?
But okay, and this is why, right? That's how we know the difference between this and this, right? So if there is a space there, your output should have a space. And if there's not, there shouldn't be. Could there be 2 spaces there? Sure. All right. Okay, so it needs to be able to deal with that. Okay. In this case, then, right, we have a space, which would be 20 is the space. Okay, what does print get crunched down to? Its token, which happens to be 99. Okay, and there's the list of the tokens on the C64 wiki. I mean, you can just Google them. For the purposes of this program, what are really the only 2 tokens you absolutely need to have? Yeah, the one for input and the one for print. Okay, and maybe you also did anybody end their program with literally end? Okay, okay, maybe you'd have the end token. It's not necessary for this program, but whatever, right? Okay, so at bare minimum, there's going to be 2 tokens you have to deal with, the print token and the input token. Okay, all right, so the word print, which is 5 bytes in my source, got crunched down to a single byte with the token 99. Okay, what follows it? What would need to follow it here after the token for print? 20 for the space, and then what? 22, and then whatever HELLOR in hex, right? I just have to look those up. Okay, so let me just say this. So I'm just doing counting by 2s, right? So I don't mean HH. What I mean is, what is the ASCII code for H? Whatever it is, right? Okay, and then the E and the we just could look those up, right? Okay, then what has to follow the 2-2? A 0-0, which is the end of line. Okay, now, what was the first 2 characters here, the line number? So the number at the beginning, before the space or before a token, okay, is in this case the number 10, which in ASCII is a 2-byte thing, right? Because it's 2 characters. Okay. What is that as a number? How do we convert a string of digits to a number? Yes, and if only you had written such a function last semester in CS271. Okay, so you remember one of the assignments was to write a string to end function? Okay, now, do you have to write the string to end function again or use your one from 241? No. Is there a built-in one in C or Python or whatever? You betcha. Okay, so yeah, how do you turn the characters 1, 0 into the actual number 10 for computation's sake? You're turning a string into a number or a string to int. Yeah? Okay, so do that. Okay, and then as a 16-bit number, okay, although in our case we can sort of ignore the fact 16-bit, because for this simple of a program, really how many bits do we need for our line numbers? Huh? We really just need 8 because our two line numbers here are basically going to be like 10 and 20. Okay. Do we necessarily know they're going to be 10 and 20 though from the get-go? Okay. Why not? Basically, yes, right? 10 and 20 is just the convention that we tend to follow. But could I have done line 1, line 2, or line 10,000, line 10,001? How do you know I'm not going to do that? I don't know. Maybe I am sadistic. Okay. So my point though is the line numbers. So what are valid line numbers? Well, okay, anything from
0 to 65,500 something.
35, right? 65,535. So integers from 0 up to that. Okay. And actually, 0 is not a valid one because that would get us confused with the end of line. So I'd start with 1. Okay. Um, but so a valid basic line number is any number between there. Okay. Now, by convention, what do we tend to do? The 10, 20, 30, and so on. Okay. But there's no restriction that we must do that. Okay. So even though you guys programmed with 10, 20, 30, and my current source code here has 10, 20, 30, you don't necessarily get to assume that that's what I'm going to have. Okay. Now, that said, I am not going to test your program with invalid line numbers. Okay. So, and what I mean by that is, do you have to do any form of input validation? Extra credit. You're funny, right? But okay, so you get to assume that the source code that your program is going to process is syntactically correct. Okay, so are we clear what I mean there? Right. So I'm not going to have mistyped print. I'm not going to have uh, invalid basic line numbers. Right? It's going to be syntactically correct. I just might be putting in extra spaces and I might be changing the line numbers. Okay, does that make sense? Yeah, okay.
I'm recording this,
Mm-hmm.
how do you want to save this so I can output it? You can output a string from only text. How do you want it?
Yeah, so it will, such that if you do a hex dump of your output, it literally looks exactly like a PRG file. Okay, now, Rippy's question is actually really important here because if you output strings to a file in, say, C, okay, how are strings stored in memory in C if you're programming in C? Huh? No. Like literally, the string is in memory someplace. If you look at those bytes in memory, what do you see? You see stuff in ASCII. Okay, what do you see at the end of the string? A string, not a text file. Strings are null terminated. Yeah. So if you just start dumping strings into a file, you might be putting null terminators where they don't belong. Okay. And so you might have to worry about that. Okay, so this is why I would personally probably process this character by character. Because what is a character in C? Well, yeah, but it's an 8-bit thing, right? I'm doing it byte by byte. Okay, so my point though is if you work with C, be careful about the null terminators on strings. Okay, is that okay? Yes.
So what is like the end goal? So when we do this, we're trying to take like a Python or C file.
Mm-hmm.
At the end of it, at what point we're like, oh, I see this now I'm done.
Okay, let me continue. The end of line for basic, right? Okay, so let me actually do one thing real quick. Let me take this. Let me copy it here. Okay. Okay. So, I'm sorry. No, that's what I wanted. And then let me open. Sorry, I need one other thing. I need. Um, oh, I never copied it over. Okay, hang on one second. Huh? Oh, because as I'm explaining things to people who come by the office, right? Yeah. Okay. So, to Cole's question, what is the whole point here? I have two hex dumps on the screen. The top hex dump is the hex dump of my source basic file, right? That has two lines, 10 print hello, 20 print world. Okay. And so this is like plain text input, right? That I could write in whatever text editor I wanted. But I can't take this and just immediately run it on the Commodore because it needs to be tokenized, right? Well, where's the tokenized version of this? It's this one at the bottom, right? So on Vice, I typed in 10 print hello, 20 print world, and I saved that file and then copied it over to my desktop and hex dumped it. And this is what I got, the bottom hex dump. I want a program that's capable of turning this into this. This? Yes, if I dragged that file back, well, yeah, if I literally dragged this file to Vice, it would load it and run it.
So you can, if you had a raw Hex Dump file exactly like the one you just showed, only that in it, it would run in Vice, and how would you use that? Also, what's the one?
That just means like 1E is it just tells you the last. What did he say? I'm sorry. What did you say, Owen? Okay. Yeah. Well, okay. So the reason the 1F or the 2.2 is listed here on the other one is because, so how long is this hex dump? It's 31 bytes, right? And what's the first memory address that's not there? 1F. No, these three zeros are this first pair of zeros is the end of basic line, and then the other set of 4 is the end of basic program terminator, right? Okay, so yeah, so to Rippy's question, right? So I've got Vices right here. Okay, all right. Let me go to my desktop. Right, I have here silly.prog. Right, this is a tokenized basic program. Oops. I can just drag it over.
It's not easy.
Well, okay, that's one way to do it. Okay. Yeah. Well, I could type it in hex. Okay. Good question. Not within the basic command prompt that we're in right now. Okay. We would need a text editor, essentially, right? Or a machine code monitor, and I could literally, actually, no, I could do it. It would just be a pain in the butt. Okay. And here's how I would do it. Okay. This is kind of crazy, but all right. So let me just, for sake of notation, what is 801 in decimal? Okay. So 801 is hex, right? What is that in decimal? Well, I need to do 8 times 16 squared plus 1. So what is that? It is, but what is that number? All right, 8 times 256 plus 1 is 2049, right? Watch this. Oops. Damn it. Oh, yeah, that's right. Damn it. Okay, hold on. Oh, that's right. I have to print it. I can't just peek. I have to. Oh, damn it. Sorry.
It's not giving you like whatever the heck is in there.
Yeah, okay. So, was it 2049? That wasn't the right number. No, it was. Okay. Right, because we've got, let's see, 1's place, 16's place, 256's place. Yeah, that's right. Okay. So let me change this to, oops. Okay. All right. So what I'm actually looking at here, let me just do this. Let me write a new program. No. Okay. So what's happened here is, yeah, and in fact, what I've done is I've essentially inspecting the memory here, right? So peeking and then listing the memory address in a decimal number gives me the basically what is that contents of that memory address as a decimal number, not in hex, okay? And now if we look at this, right, what do we see? Edit memory? Yeah, it's poke.
Okay, so Paul lets you so you could basically rewrite some of those chunks and start really quickly.
Yeah, you can okay, so this is something that you couldn't do when we were working on the Raspberry, right? On the Raspberry, how did you interface with memory in a program? Right? You could put things in, you could store registers to memory or load from a memory address to a register. Could you store any data to any memory address of your choosing?
No, it had
Why
limits.
not? What would happen? There were limits, and what would happen and you would get a seg fault if you didn't obey those limits, right? There is no such thing as a seg fault on this machine, okay? You have complete autonomy to write data to any of the 65,535 memory addresses that you wish. Now, with this power, bad things could happen. Okay, for example, if you start writing to memory addresses that contain, for example, where the kernel is, or where the basic ROM is, yeah, bad things could happen. Okay. But if you overwrite certain memory addresses, then you could actually change. So, for example, if I wanted to change, you see how the text is light blue and it's dark blue and the border is light blue? If I change certain memory addresses, I can change all those colors. Within the limits of the Petsky color palette, yes. I don't remember the command or the address right now. I'd have to look it up. No, I'd have to look it up. Rippy, there are 65,536 memory addresses to keep up with. Do you think I have all of them memorized?
Yeah.
Hell no. Okay. Yeah, well, I'm not that professor. Okay. Okay. So, point being, what we've essentially done here, it's not a hex dump because it's not in hex, but I've dumped the memory to the screen, right? And now let's look at everything and see, does this make sense? Okay. So, what do I see? Right? Well, hold on. Let me just think for a minute. Yeah, okay. I'm not sure why this is 16 because this should be 01. It is. Let me think about that because I think this should be 01, not 8, not 16. Let me just make sure that I haven't made a reversal someplace. Okay. But in the program file, it should be 01, then 08. Right. Okay. So 8. Do we recognize this? Okay. Then what do we have? Okay. The pointer to the end of the line is what should come next. Actually, hold on one second. Oops. I'm just making sure I'm not having an off by one error. Okay, no, I'm good. We're good. There's no, I'm not, 2048 would be 0800. Yeah, okay. And I did start with 2049, right? Because I started with 2048 plus 1. Yeah, okay. That's a little surprising to me that it's that, but um, I'm not sure, Rippy, why it looks like that. Well, let's keep going and see if we can kind of suss out what's going on here, right? Okay. Because what should the first two characters correspond to? 0108, namely the pointer. Okay. Okay. And then what should the two after that point to? Pointer to the end of the line, which this doesn't look like correct either. Let me just double check that I've got the right memory address in the first place here.
Maybe it's not actually 0108. Maybe it's like that. It's like the actual place. So it'd be like 16 squared plus 8 instead of the actual memory address you'd expect.
No. Okay, so here's the memory map for the entire machine. Right. 0801 2049 default basic area. Okay, so that's interesting. Let's go back here. And so, I mean, what am I expecting to see here? I'm expecting to see 01, 08, okay, followed by a pointer. Okay, that 32 is 20 in hex, so that's a space. Okay. 129, if I do 9 times 16 plus 9, I get what? 153. And I don't know about you guys, but I don't see 153 until down here. Here, let me just do more of this just for sake of, oops. Well, I printed more stuff. Okay, so what am I trying to look for here, right? I'm trying to look for, so what do I expect to see at the end of my basic program? Right, I would expect to see 0, 0, 0. Okay, but I've also got these 255s here. Okay, so actually here they are. There it is, 0, 0, 0. Okay, so let's work backwards from this. Okay, so there's my end of line terminator, or end of line and end of program terminator. What is 5, 6? Yeah. Uh, Here actually. Okay, yeah. So that's the first one, or the last. Yeah. Okay, sorry. So what is 73 as decimal in hex? Well, what should we be expecting to see there? At the very end of a line, what should we be expecting to see? Well, what was the very end of our source code? Oh, guys. Oh, I am such an idiot. Okay, I'm sorry. Okay, let me back up a minute. Yeah, okay. How many lines of basic do I have here? 3. Okay. What I'm printing out is the hex dump for this program. So the program is printing its own hex dump. Not, okay. So what's the first token that I should expect to see? Whatever the token is for 4, not for print. That doesn't come until the second line. Okay, so it's smoking something. Okay, but yeah, but I wasn't Rippy, right? Because
you were describing it just fine.
Yeah, because your professor's incompetent. Okay, so let's back up a minute. 129. Okay, in hex, what is 129? Well, something, right? Well, it's 128 plus 1. 8, 1. Okay, now let's look at the list of basic tokens. Huh, would you look at that? It's 129 decimal. Okay, so back here, 129 is the basic token for 4. 32 is a space, right? 73 in hex is the letter I. 178 is equal, I think. Let's look at the Petsky. Actually, no. Okay, so this is one annoying thing. The arithmetic symbols and some of the mathematical symbols also get tokenized, right? So is there an equal symbol in Petsky? Yes. Okay, for like a plain text equal. But it also gets tokenized here as 178.
So
Okay.
depending on whether or not it's within quotations, will it go into the Petsky or tokenized version?
I think if it's in quotes, it will stay in Petsky.
So there's two versions.
Yeah, that's what I would expect to see. Okay. Okay, so what is 178? That's the equal symbol, right? So I have the letter I, and then an equals, and then what's next after that? The number 1 in this case, which is,
49.
wow, that makes total sense. Oh, no, sorry. That's the letter I.
So you said the letter I was 73. It says I equals 49.
Okay, hold on. 49 is the Petsky number for the number 1. Okay, so we're good. Okay, then there's a space. Okay, and then 164 is what? The tokenized version of the word TO, 2, right? Because what was my loop here? 4I equals 1 to 32. Okay, all right, so this is the tokenized word for 2. And then I have, I need the number 3, 2.
No, you need number 64 space and then 54.
Oh, right. Okay. Yeah, space. And then 5, 4 is the, sorry, 5, 4 is the 6. 5, 2 is the 4, right? Because this is in Petsky, right? Okay. And then a null terminator for the end of the line, because that's the last character. Okay. And then 3, 3, 8. So
They split it. They split 54 into 2. They split 64 into 2.
oh no, I know how it is. Okay. Huh? They split what now?
You said they split 64 into 2 memory addresses?
Yes, because it's the 6 is a single character and the 4 is another single character, right? So it's storing that number not in numeric form but in text form. Well, that's what it did with the 1, right? 49. That's the 1 symbol, or the 1 encoding, right? So this makes sense. Okay. All right. So let's back up here because there's one thing maybe I it's off by even more than I said. Okay, what were we expecting to see at the beginning here? 01 followed by 08, which would be the starting memory address. Okay? But what do we see? 16 and then 8. Okay? So that would be in hex, that would be 08 as a memory address, 0810, right? Because this is 16 and that's 8 and it's written in reverse order. Okay. That is the pointer to the end of the first line.
What's the next two?
Huh? The next 2 is the line number.
Yeah, but what about the other stuff we've been shown in multiple other instances where it has the starting location,
Okay, good point. So let's think about this. Do I need to load the starting location into memory? No. Right. So in our file, okay, that would be saved on disk, what would we see? And then, okay, so what I would expect to see on disk is 0108 and then 1008. Yes. Okay, it makes sense because we have a short program. Okay, yeah. So, well, and the pointer, the second thing, is going to be the end of the first line. And how big can your lines be at most? 80 characters. Okay, which is not that big, right? Okay, so in memory, the oh, this makes so much more sense now. Okay, yes, okay, I finally get it. So, okay, let's go back to where we started the day, right? I put up a hex dump, and I said, oh, look, this is pointing to the last character of a line. Okay, but I was off by 2. Well, I was off by 1. We fixed that, but I was then off by another 2. Okay, so let's think about why. What gets loaded in memory address 0801? The third byte of my code, not the first byte. Okay, so what that means is that what I thought was pointing to 2 characters prior is actually 2 characters later, which is the first part of the new line. Okay, so let's think about this. All right, looking at my screen here, I'm pointing at the 16. What address is that in? 0801. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? So the 0810, which is 2049 plus, or 2048 plus 16, right, is pointing to where? Where the 33 is, which is the beginning of the next line. Okay? Yes, the pointer points to the next pointer. Yes. Okay, so what I said about the end of the line is wrong. It's actually the beginning of the line. Because do we load the starting memory address into memory? No, this just tells us where to start loading stuff into memory. But we don't need to, why would we load the beginning memory address itself into memory? Do we need that information? No, the rest of the program has everything you need. Okay, is this starting to kind of make sense? Sort of? Okay, so, all right, so let's go back through this, right? 16.8, okay? What is 16 in hex? 10, okay? Good? All right, so 1008 would be the pointer to the next pointer, okay? So I've got a pointer, that's the first 2 characters, or first 2 bytes. Then what do I have after that? Line number, right? What's the line number of the first line? Line 10, right? And so I've got the low byte 10 and the high byte 0, right? Why do I need 2 bytes for my line numbers again? Because they're 16-bit things, right? So even though I didn't need the extra 8 bits here, I need to encode all of them as 16-bit line numbers. Okay? Is that okay? Okay, so next, what do I have? 129, what was that? That's the decimal form of the token for the word for is in a for loop, right? Followed by a space, followed by the letter I, followed by the token for equal, followed by the symbol 1, followed by a space, followed by the token for the word to, followed by a space, followed by the 6, then the 4, null terminator, end of basic line. 338. What's that the next thing? Yeah, it's a pointer, right? So what memory address in decimal would be the next location? It'd be whatever 2048 is plus 33. Okay. All right, so this is my next pointer. Then 20, what's that? And 00. Line number. Okay. 153, that's the token for print in decimal. It's 99 in hex, right? So basically, well, okay. Basic, and this is one of the things that's both annoying and nice about it. All of the numbers that it just spit out here are in decimal, not in hex. Okay. Would it have been nice if they were in hex instead of decimal? Okay. Basic only displays stuff in decimal, never in hex. Okay. Now, a much later version of it, I think Basic V7 that they started shipping with the Commodore 128, I think you had options for displaying stuff in hex as opposed to in decimal, right? Okay, but what we are looking at is essentially the same as our hex dump. Sorry, where was I? Here, right? We are looking at, well, it's not this one because, here, let me just save. Hold on. Hold on a second. Okay, so let me save. Uh, well, sort of. No. Yes and no, Rippy. Let me go back to Droid. Where is it? Oh, sorry. It attached a different drive. It I didn't have the right D64 attached. There it is. Okay, so here's what I'm going to do. I'm going to put this, on the left half of the screen. And I'm going to put Vice on the right half of the screen. Okay. And now what I want to do is I want to look at the hex dump down there at the bottom left of the screen and compare that to what I've printed, that sequence of numbers that I've printed on in Vice. Okay. And what I claim here is that these are all the same thing, starting with the third byte of my hex dump that's down at the bottom left of the screen. Okay. What is 10? This is in hex. What is 10 hex? 16 decimal. What is 8 hex? 8 decimal. What is 0A hex? 10 decimal. What is 0? Well, that's 0. What is 81 in hex? That's equivalent to 129 in decimal. 20 is 32, and so on. Right? Okay. So what I've just demonstrated is that, well, that literally is what's in memory. Okay. So how would I have done this when we were in 241 on the Raspberries? How would I have seen what was in memory? How did we do that? Yeah, I could print it, like using printf or something, right? But we also did things in GDB, right, where I could do the x slash something or other to see a dump of memory within GDB, right? That's essentially what we just did live on the Commodore. Okay, what's the only problem? It's in hex, or sorry, decimal instead of hex. Yes, I had to write a program. Okay, and so this is a fair point. I had to write a program. Where did that program therefore get loaded? At the beginning of the basic memory, which meant, could I have a program that dumps a different program? Could I write a basic program that memory dumps another basic program?
Technically, yes, but you have to start with an offset knowing where it is.
Right, and I can't start with an offset in basic.
Well, what I'm saying is that, like, you could have done before jump at, like, the very end or the very beginning, and then knowing where that for jump started, you could say, okay, we're
Yeah.
going to ignore this.
I'd have to basically embed my program within a larger program.
Yes.
Okay. The better way, of course, would be to write a machine code routine that does essentially what we just did, because the machine code routine I can put wherever I want in memory. Then I can just call it after loading something. Yeah. Okay. So let's go back to my hex dumps here. Okay. So do you guys accept? I mean, I've printed way more memory addresses than I needed here. Okay, I just printed 64 just to make sure I didn't miss something. Okay, but does this make sense? Sort of. Okay, so back to Adam. Okay, so if I want to load a program into memory, a basic program, I need a file that looks like the bottom hex dump, right? Okay, and in fact, I drag that file straight over in device, and when you drag a program file in device, it loads it and runs it immediately for you. Okay, or I could have put it on a D64 and then loaded it and then run it, right? But point being, I ran it, right? For it to run, it needs to look like that. But what did you type in your modern text editor? So you typed in your modern text editor the top hex dump that's on the screen. The thing that needs to execute is the bottom hex dump on the screen. Okay, so what am I asking you to do? Make a program that takes this and spits out that. Basically, yes. Okay. Okay, the regardless part is where we need to be careful. Okay, so how many lines was our program? 2, right? Our stupid 10 print. Okay, so how many lines was the program you wrote that's for the thing due tonight, where it asks for a thing? Yours was 2. Okay, so I will give this program that you give me a 2-line program that looks like what you gave me. What are the only 2 things about your source code I might change? The number of spaces, and, well, I could change the string, right? So, like, let's say your string is like you prompt the user, please input a string, and I could just change that to please input. Okay. And then the line numbers. Okay. Those are the only three things I might change right now. Did you have to do the program for tonight? Could you have done that in 3 lines instead of 2, or 2 lines instead of 3, whichever?
1 line.
Could you have done it in 1 line? Technically, yes. Okay. And so whichever way you've given it to me, I want it to be able to tokenize in that form. Okay. So, and the reason I'm being a little limiting here is because like I am not asking you to write a program that can tokenize any basic program ever. Right? That's a very big thing. What I'm asking you to do is to write a very small chunk of that that's capable of tokenizing just the program that you've got, or things that look very similar to it. Okay, fair. Okay, because if you know exactly what the input is going to be, then you could just spit out the output because you could even hard code it. Okay, there's no processing to be done. Okay, so you are going to be producing something that can spit out the tokenized version for similar input to what you have. Okay, so what are the things that might change? Line numbers, spaces, and maybe the strings. Okay, I'm not going to change anything else. All right, so how would you test your program? Like, let's say that the program I wrote was 10 print hello and 20 print world. Okay? If I wrote this tokenizer and wanted to test it, I'd first give it what I have right here and make sure that I got the correct output and that it worked. Okay? How would I modify my source code to test whether or not it still works? Could change the line numbers. I could change the strings. I could put some extra spaces in, but I'm not changing the overall structure in the sense that the first line is still print, the second line is still print. I'm not putting new token words in and so on. Does that make sense? Kind of? Yeah. Okay. What language are you going to do this in? This tokenizer. Yeah, whatever language you choose. Okay. Python, C, Java, AR64 assembly. Okay. If you want to do it in x86 assembly, fine. Okay. Huh? That might be a subsequent assignment. No. But in order to do that, we have to talk about how to do disk access within BASIC, which is something I was hoping to get to today, but obviously we won't. Okay. Because, well, time is fleeting. Okay. And then what might a subsequent assignment be? To write it in 6502 assembly, right? You noticing a theme here? Right? Yeah, same thing in different languages. Isn't that always, that can be an illuminating thing, right?
Yeah.
Because you really learn about different languages, but also about how to do this system, right? Okay, because, okay, and here's why that's important. If we were doing this exact process in 1985, right? If we were all, it was 1985, and you guys were all sitting here. None of you were born in 1985. None of you were twinkles in your daddy's eyes. I was going to say. And I was going to say, we're almost getting to the point where your daddies weren't even twinkles in their daddy's eyes. No, how old your parents are. Because, like, I was born in 1982, right? Huh? Right. So, like, Drake, your dad and me are basically the same age, which is kind of scary. Like, I literally could be Drake's father. 82. Yeah, November of 82.
parents were born
Your dad is 74 years old?
Oh, he was born in 74.
Oh,
My dad
right.
was born in the 50s.
Yeah, so your
Yes, it
dad was 8 years old when I was born, right? Now, what's frightening is, like, Drake, your dad was your age when he had you,
Yeah,
right?
and I have a little sister that's like the age difference between me and her is pretty much the same as between my dad and I.
That's crazy. Yeah. So, okay. Anyway, so, okay, so let me get back to the point. Why were we flashbacking to 1985? Okay, so we could drive our muscle cars and listen to our rock music with lots of hair, right? But if we were to write, if we wanted to do this process in 1985, how would we have, what tools would we have had at our disposal? We would have had BASIC and we would have had a machine code on this machine, right? And books, actual dead tree books, and no internets yet. Okay. All right. Am I kind of making sense here? All right.
You're gonna need outside help, but
That's fine, right? Okay. So for the tokenizer, what I need you to do, other than obviously writing it and give me the source code for it, is instructions about how to run it. Okay. Because if you write it in C and you do file arguments as command prompts where you can pass data to a program through the command prompt, great. If it's in Python, obviously things will be a little different, right? So I need some instructions as to how to run your stuff. Yeah, okay. All right, so let's quit here. So Shane, I hope you feel better, and I'll see you guys on Thursday.